Okay, now we're going to take a look at the multiplication method. The multiplication method is the same as the simultaneous substitution. We're trying to find the intersection of two lines. So it's just four straightforward steps. We set our inequalities to equalities, in other words, set either greater than or less than sign to an equals. Multiply by negative of the coefficient. Then we add the two lines together and solve for the first variable. We substitute the first variable into one of the equations and solve for the second variable. Okay, here are the exact two constraints we used in the substitution method. Now we're going to use the exact same two constraints in the multiplication method to show you that they're equal. First thing to note is I took my two constraints and I just plotted them out here as a visual representation. First thing you notice, we have our feasibility region down in here. These are both less than or equal to constraints, so they have to be below both lines. So this is our feasibility region in here. That gives us four extreme points. One at 0, 0, we'll call that A. We have one where it intersects with the x1 axis. So this is coordinates of 3.3 and 0. We have a third at where it intersects with the x2 axis. So this coordinate is 0 and 3. What we're trying to determine is the coordinates at this point here, where the two lines intersect. Okay, so the first step is set the inequalities to equalities. So you can see that I've replaced the less than or equal to sign in both equations with an equal to sign. The second step is to multiply by a negative coefficient. We have the goal of canceling out one of these variables. So we want to find the negative of one of these coefficients to cancel the two out. For example, I could multiply by 8/9 and cancel out the first variable. But the math is pretty difficult there, so why don't we make life easy on ourselves? And I notice 2 times 7 equals 14. So what I'll do is I'll multiply the second equation by -7. So my first constraint remains the same. Now I multiply through by a -7. So 7 times 9 is 63. 7 times 2 is 14. And 7 times 3 is 210, or -210. So there, I've multiplied by a negative coefficient, so I'm going to make my two, in this case my x2 variable, cancel out, because I have the 14 and the -14. All right, so step 3 is to add the two together. So simply now, I add together 8 and -63, so this becomes -55x1. 14 minus 14 is 0, so 0x2. And finally, 40 plus -210 is -170. So I have -55x1 equals -70, 170. x1 equals -170 over negative 55. So my value for x1 turns out to be 3.09. So there, I've solved for the first variable in the equation. x1 is 3.09, excuse me. All right, now for the fourth step, we substitute the variable back into the equation. From step 3, we determined that x1 was 3.09. So I just took constraint 1 here, but you could substitute back into constraint 2 also. You'll still come up with the same answer because there's where the two lines intersect. So I just put the 3.09 right in for x1. Now I just solve for x2. So 8 times 3.09 is 24.72 plus 14x2 equals 40. 14x2 equals 40 minus 24.72, which is 15.28. So x2 equals 15.28 divided by 14, and x2 equals 1.09. So I know the coordinates where the two lines intersect is x1 is 3.09 and x2 is 1.09.